Hello everyone, this is Daniel Bentinck and we're continuing with part 2 of rendering 360 degree images. This is where we'll go over rendering a material from a sphere. Let's go. So what if you wanted to, say, make a shader for like an object, a sphere or something? Like what if you've made a planet, you've got your planet shader, and then you want to bake that out into a set of maps? Well, what you'd do is you'd basically, I'll bring in my sphere, which I've had here, just hidden. So I'll click the I to unhide it. There we go. You can see I've set up this sphere right here. I'll go back into render view. And it's basically got this Earth image that I got off Solar System Scope. I'll leave a link to that site down in the description. But with my Earth material, I'll just change my shader to the object panel. There we go. Now we can see where I've got my Earth texture applied right here. And for a 360 degree image to work on a sphere, you actually need to set the texture setting from flat by default to sphere. That way it wraps around in the shape of a sphere. And then you just need generated as the coordinate, and you can see it's working just fine. All our continents are showing up. Texture looks good. Now, the reason I'm demonstrating this is because the transforms you need for the actual texture to appear correct are different compared to if you were just trying to render out your world or your environment. Now, one important thing to note is if you're trying to do this and you're trying to get your sphere object as your entire 360 degree view, you need your camera to be inside the actual object, which is fine for us because as we can see, our camera is in the very center of our sphere, which is what we want. So if I look at my camera view, you'll see that now with our sphere visible, we get this Earth texture. But I'll actually show you the original in GIMP. So I've also got the Earth texture in another layer, so I'll bring that up. There we go. You can see this is the texture. And as you can see, something's a bit wrong with our version in Blender. So you can see what we're seeing through the camera is sort of an inverted version of the texture. And the reason for that is because the actual material, or the sphere, the texture is wrapped around the outside of it, because the outside is sort of the proper side of the sphere. And then by looking at the inside, we're seeing an inversion of it, of that same texture. So that's easy to fix. You just need to go to your camera, go to the object properties, and we'll adjust our transforms accordingly. So first you need to actually scale your X by -1 to flip it around. And there you go, you see things are the right way around. And you also need to just have your X rotation at 90, which we've already got. That way our camera's facing forward. But you also need Y at 0, which is fine. And you also need the Z to be at 0. So we set it to -90 before because that's the way it worked for when we were rendering out our environment texture. But when we're rendering the inside of a shader like with this planet, because we're seeing the inside of the object and it's inverted, we just need to adjust this rotation as well. And there we go. Now it's rotated to the right point and it looks the same as the original image that I've opened up in GIMP. Alright. And basically you just render that out. Now, say you've actually got a complex procedural shader that you've made in Blender and you've applied it to your sphere, like if you've made, say, a procedural planet and you wanted to actually render this out, each map, so you could create a full material with it. And that's basically the reason why I've shown you this, is say if you wanted to do something like that. To do that, what you would need is to actually set up your shader in a specific way. So you would actually need to render each different socket of your material separately. And what I mean by that is separate things like color or roughness or height information. And I'll show you what I mean now. So if I go into render view, you can see I've just got a very simple shader. It's actually not even a shader. It's just I've plugged the texture, as you can see, straight into the surface output. So there's no real shader information. It's not taking into account any of the lighting information from the environment. It's just the straight up texture and that's it. So I'll start by adding in a shader. We'll add in a principled BSDF, since that's got all of our properties like roughness and all that. There we go. Now you can see it's behaving like an actual shader where it's taking in the lighting of the environment and everything. And our texture map is plugged into the base color where it should be. And now let's actually quickly sort of create a fake shader with this texture map, just really quickly. So I'll duplicate this map and make sure to plug my mapping into my vector. We'll plug this into the roughness, and then I'll duplicate the map again, and then I'll plug this into my normal. And then to make the normal work properly, I'll get a bump map, plug that in just before. I want to make sure the texture is plugged into the height instead of the normal. There we go, now it will behave like a proper height map. Another thing I want to do is actually to add in a color ramp. And popping that in just before the bump node will just ensure this image turns into a black and white map. So as you can see, these points are black and white, so it's going to turn this colored earth texture. If I just plug that in, you'll see. So it's going to turn this result into this result, a black and white version, because height is only black and white. And the same with roughness. So we're going to plug the color ramp into just before our roughness as well to turn that black and white. And then I'll just plug my full shader back in. And you can see that sort of working. It's not very accurate because it's just the color map being converted into other maps, but it's doing some interesting stuff. And I'll just pull over my one of the points on my roughness. So I'll grab the white, pull it over, and you can see that sort of made the land parts more rough and then the water parts more reflective, which is sort of accurate. But now that we've got our simple shader set up, I'll show you what I mean about rendering the individual sockets out. So usually what you do when you're trying to get maps output from an object, you would do something called baking, which takes all the information of each parts of your shader, like color, roughness, and height, and it basically turns each one of them into its own separate map. And Blender actually does have a baker. If we scroll down on the render tab, you can see it just here. But it's not going to work for us because we actually need to render out using our 360-degree camera rather than baking from our object information. So since we have to use our camera to get that 360-degree image, we actually need to render normally like we do when we press F12. So what I'm going to do is, say if I wanted my color information, I just grab my color socket, plug that straight into the surface, and now you've got your color information. If we go to our camera, there we go. You can see the color map just there, and you can render that out as is. You've got a color map. Now if you want the height map, you get your height socket, you plug that into the surface, bam, you've got a height map, and you just hit F12 to render that one. If you want your height, you get this. You don't want to get the bump map, you want to get just before it. So grab this, plug that in, we've got our height map. And that's what I mean by splitting up the different parts of your shader. So if you've got a procedural shader, whatever you plug into this base color, you plug into the surface and render out your base color. Whatever you've got plugged into your roughness, you then plug that into your surface and render your roughness next. And you go through that, plugging each socket in one by one, rendering each of your maps out as a normal image. It's a bit tedious, you have to adjust it each time, but it's not too difficult to do once you've set up your shader, and it just allows you to render out each map as an image, and then you've got all these maps that you can now use as a material. And that's basically what I did for my planet series when I baked out my procedural planet into a set of texture maps. And yeah, that's just a nice way to render out your shaders as a 360-degree image if you've got them onto a sphere. Alright, I hope you guys enjoyed this tutorial. Be sure to check out my Twitter and ArtStation. I've got links down in the description to all the places that I'm active on. And be sure to like and subscribe if you enjoyed the video. Alright guys, have a good day. See you next time.